Hello dear students, welcome to all of you on the playlist on the process calculation, and we are solving some problems on the process calculation. So the problem statement, my dear friend, here is that we have to balance an equation that is given to us, and we have to calculate the stoichiometric coefficient a1, a2, a3, a4, a5 and a6. So as we all know that conservation principle states that matter can neither be created nor destroyed, however it can be changed from one form to the another. All we have to do is we have to apply this conservation principle using atomic balance. So first we will look in the reactant, and then we will equate with the product. So first we have to write the atomic balance for the arsenic atom. We have two atoms of the arsenic for stoichiometric coefficient A1, and we have no more in reactant, and further we have just one arsenic atom for stoichiometric coefficient A5. So we call it equation 1. Same procedure we follow for the sulfur atom. We have three sulfur atom for the stoichiometric coefficient A1, and we have no more in the reactant, and we have one atom of the sulfur for the stoichiometric coefficient A6. So that is the balance, my dear friend. We call it equation 2. Same procedure we will follow for hydrogen atom, and we have two atom of the hydrogen for stoichiometric coefficient A2, and we also have one more for stoichiometric coefficient A3. Now the turn is for product, and here is just three atoms of the hydrogen in the A5, and we wrote, and one more two hydrogen atom for the stoichiometric coefficient A6. So we called it equation number 3. All you have to do only to write the atomic balances for the each of the atom. So the next turn is for oxygen. We have one atom of the oxygen for stoichiometric coefficient A2, and we have three atom of the oxygen for stoichiometric coefficient A3. And now the turn is for product. We equate the equation, and now we have one atom of the oxygen in the stoichiometric coefficient A4, and we have four atom of the oxygen for the stoichiometric coefficient A5, and four oxygen atom for the stoichiometric coefficient A6. So we call it equation number 4. Now the last turn is for the nitrogen, and we have just one nitrogen atom in the A3, and furthermore we have one nitrogen atom in the A4, and we have nowhere nitrogen atom in the balance in the chemical equation. So we have these 5 equations, and now we need to solve these 5 equations, but first we need to fix any of the stoichiometric coefficient. So we use A1 equals to 1. So if we put A1 equal to 1 in the equation number 1, we get 2 equal to A5, and in this way we get the value of the A5 equal to 2. So we have calculated stoichiometric coefficient A5 equal to 2. So now we have two values, A1 equal to 1 and A5 equal to 2. Now putting this value in equation number 2, 3 into 1 equal to A6. So we get the value for the stoichiometric coefficient A6 equal to 3. Now my dear friends, we will put all these value that we have calculated in equation number 3. So we have here value of A1, A5 and A6. So putting these values, Finally, we have equation 2a2 plus a3 equal to 12. So we call it equation number 6. Now we have an equation in two variables. Now if we have another equation with the same variable, we can easily calculate the value of the a2 and a3. And if we put all these values of the stoichiometric coefficient in the equation number 4, we get another equation. The equation that we get is a2 plus 2a3 equal to 20. We call this equation 7. So now we have two equations 6 and 7, and we can easily solve them simultaneously to get the value of the a2 and a3. So we have 2a2 plus a3 equal 12 and a2 plus 2a3 equal 20. From equation number 7, we get a2 equal to 20 minus 2a3. So if we put the value of the a2 in the equation number 6, so we have 40 minus 4a3 plus a3 equal 12. So finally we have 3a3 equal 40 minus 12. So finally we have a3 equal to be 28 by 3. So now we have the value of the a3, and we have the last value that we have to calculate is a4 and the a2. So a4 value we can calculate if we put the value of the a3 in the equation number 5. So equation number 5 here is a3 equal to a4. So a4 values came out to be 28 by 3. So 1 and the last value of the stoichiometric coefficient that is left is a2. So if we put the all these value in the equation number 7, we get a2 equal to 4 by 3. Now this was equation that we was given to balance. So as we have calculated the value for the stoichiometric coefficient a1, a2, a3, a4, a5 and a6, so we can easily put these value, and here we have a balanced chemical equation. So value for a1 we have assumed to be 1, and value for a2 we have calculated to be 4 by 3, and value for the a3 we have calculated to be 28 by 3, and similarly we have calculated for a4 to be 28 by 3, and similarly for a5 we have calculated in the previous slide to be 2, and similarly a6 we calculated to be 3. So now these values are in the fraction. So the best way to have a good balanced chemical equation to be in the natural number. So we multiply by the 3 and we get, so this is the balanced chemical equation, my dear friend. This is the procedure that we will follow in balancing any of the chemical equation.